If you actually worked out how much it costs to produce that bike, you would never ever set off producing that bike. Commercially, if an accountant had ever been involved in this, it would never have happened. No offence to accountants.
Simon aspired to have a bike for years and years, back as far back as 2004, 2005.
There've been a few iterations and changes. We started from like an aluminium front triangle, and then it moved on.
It was once a downhill bike, so Guillaume started developing geometry for a downhill bike. At one point, it was just like a cross-country trail bike.
Yeah, it's what Hop's always done, sort of make things for ourselves. He wanted to ride it, so that was the bike we were going to ride in the Alps, going to ride Whistler, going to ride that. That was the bike we all wanted to ride. So you make that first.
So as soon as we were able to do so, we converted the 3D CAD model into a three-dimensional form by printing it on a 3D printer in sections. You never get an idea of scale until you actually see a physical model in your hand.
Carbon fibre seems to be like a bit of a black art, and you can't get much information from people. People don't want to share what they know.
And I suppose with us being toolmakers, and toolmakers think they can make anything, so that's why we had this idea that once we actually crack the material and realise how to work with the carbon, we can actually produce anything, same with the seat posts, the handlebars, and then onto the frame.
We start off with a big slab of aluminium. We get it water jet cut to the rough shape of what we want the mould to be. Each half weighs about 48 kilogram, Ash.
48 kilos per half.
Go in with as big a cutter as you can to rough it all out, get the main of the meat out, and then you come in with a ball nose cutter which does the fine detail. This join line, there can be a step on it, and you've got to sand that step out. And the problem with that is you may start sanding through the top ply, which takes the strength out of it. So if you can get your mould to line up absolutely perfectly, which we can with machinery we've got, and the skills.
Yep, and the skilled engineers that's doing it.
So you can come out with a perfect mould and get the perfect frame. We're probably one of the few firms in the world that can actually do that, aren't we? That can actually make the moulds
ourselves.
from Guillaume starting to design the large frame to actually pulling one out of the mould was 6 weeks.
To determine your ply templates, by plies we mean individual cut pieces of carbon fibre pre-preg that go into making this 3D form. You'd start with the surface model and section it into each key area and basically flatten those surfaces out into two-dimensional cut files for our cutting machine to cut out of the flat sheet material. In terms of this carbon front triangle alone, 177 individual pieces of cut carbon fibre that go into the mould tool to create this front triangle.
We now have like a carbon fibre layup expert working for us, not just as a consultant.
I've been in composites for the last 30 years. It was aerospace at the beginning mainly, and then British cycling track frames for the Olympics. In the actual frame, there's 4 different types of carbon. 150 gram, 245, and then to really bulk it up, this is 416 grams. Such as in the headset and bottom bracket and these, it really needs to be strong. But like in the tubes, you probably want it a bit stiffer. The strong material, some of these woven fabrics will give a little bit more, what depends on the fibre, but it'll give it more strength, and it's quite easy to lay up really. As in the UD's pretty, which just runs in one direction. So that'll keep all your stiffness and strength in the one direction.
So in these key areas, by using FEA and stress analysis software, you determine what kind of load conditions these are put under, and that dictates your ply orientation in these areas. Where there's a lot of load on the head tube, you'd put more unidirectional carbon fibre in to distribute those loads.
Called a 090, the weave. There's fibres in one direction and it's woven in another direction as well, so we call that 0-90. So if you turn it,
you can optimise your orientation of the pliers in those areas just to cope with the loads that it's been subjected to.
Once we got into this making our own bike thing, we weren't then no longer hands tied by industry standard.
We had not a problem, but with the industry standard, you have to stick in a box, and you're somehow restricted. So we decided just to discard them and make things like we think we should be done.
Yeah, some people kind of at first start to criticise a little bit, saying we were creating new standards, but I don't want to think we were creating new standards. We're not creating new standards. They're not for anybody else. They're just for us. That's it. And we don't try and dictate to anybody what they shouldn't do. They're just ours, and it works. Yeah.
basically it's done on like a Formula One chassis type effect. That you lay the two halves. It's got the carbon fibre, proud of the mould. The other one drops down shorter. Then obviously put the two halves together with a bag inside, obviously, and clamp it together, basically. Heat it up in the press and get the pressure in it. It's as simple as that, really.
The day the first one got built up, we weren't sure on what it was going to be like. And Simon brought it to car park. We rode it round car park and said, yep, it's a go, didn't we? And that was it. Make some more, and that's how it worked.
Well, it's like, we always joked, didn't we, about that first bike being a £500,000 bike, but
that was each.
Each. But in terms of time and money spent, yeah.
It'll all work out. It'll all work out all right in the end, won't it? We said if nothing comes of it, it lifted everybody. With everything else, it just lifted it, and people felt great that we actually had a complete bike.
For geometry, it's very difficult. It's like you won't find the ideal geometry that suits everybody. It's like a pair of trousers. You have one pair of trousers, it's not going to fit everybody. So we did several designs just for the suspension, kinematics, and adjusting the rear travel. We had to play about with the evolution at the time because everything moved on from 26-inch to 27.5.
We looked at certain areas and what have you, and one of the areas where we felt there could be an improvement is in the wheel. With now having like 12 gears on the back and one thing and another, they've pushed the widths of the frames. What we also thought was that there's no point in going wider with the other side because you're just going out into fresh air. So what we've done, we've made it asymmetric and pulled this side in almost 20mm because we've got actually a much bigger location on the frame with a 25mm location. But the overlock ring, or overlock nut, is only 130mm. But we've effectively got a boost type rear end. The other key thing is the axle, because it doesn't have an axle. So what we have, the bolt is 17mm, and that's like massively rigid, as opposed to something out here with only a 12mm spindle. So
we were always very much of the opinion that you can't beat putting bolt through something and a mechanical fastening. But yeah,
we as engineers, with mechanical interfaces, we were thinking of bonding as being, it's like gluing something, it's like super glue, and that's what we all sort of said. And then we bonded something for the first time and tested it on our test beds, and we couldn't believe it actually sheared off the aluminium before the bonding broke.
By refining the mould tool, it's evolved so that we've got loose tooling inserts into all these locations. That controls the surfaces that we're bonding our metallic inserts into to give us closer dimensional accuracy over these critical areas.
So the bottom bracket is sort of a hybrid between a press fit and a screw-on one. But also we're putting a center tube in there, so you don't have to fine-tune the preload on the bearing. because you find if you preload your bearing too much, they'll wear quick. So because of that center tube between the two inner race of a bearing, you can just tighten the crank like it should be, and you don't have to worry about anything else. Yeah, we thought what was the best for one function, and for instance the brake, we didn't like the post mount and the old IS standard. It's nothing new. It's been used on motorbikes for ages and ages. Radial mount is just the caliper is positioned perfectly radially on the disc. So if you need to change from one size to another, you only need a couple of spacer. You don't need to change bracket and so on.
We kind of decided early on in the process that we were going to just clear coat the frame and try to get as near to perfect component out of the mould as possible. All it needs doing is literally rubbing down and then lacquering with a clear coat lacquer to produce a natural naked carbon fibre frame.
Well, we've got a reputation to live up to, haven't we?
Yeah.
At the end of the day, it's, you can't put a crap product out there.
But the attention to detail that is necessary to achieve as near to perfect finish as possible, that all contributes to the length of man hours it takes to actually place those pliers of pre-preg into the mould tool. That's why it takes a number of days to produce a frame rather than hours.
So it was a team building exercise.
It was everything.
A team building exercise to make it all. It was. That's what it did.
To ride your own bike, it's something very special. I remember the bike came here by the post last spring, and it was raining. And usually with this weather, I'll just wait for fair weather to go riding. But this time I just couldn't wait. So I put the bike together and I went riding in the mud, and it felt really good. And I did send an email to Simon and Ian, who started this project, like saying it felt like an achievement. It felt like climbing a mountain and finally getting to the top, and it's very special.